Hi, my name's Sherry Drexler, and my partner, Danielle Miller, and I were assigned the chi-square test as the test that we were to do our presentation on. And the article that we chose to evaluate that uses the chi-square test as one of the tests to tell what the research came out as is called Females in the Juvenile Justice System.
Thank you, Sherry, for that introduction. So looking at this article, we are looking to find the relationship between mental health history and family dysfunction within the female juvenile delinquent population. This is important to the field of social work, as many times we will be working with children who struggle with issues such as recidivism and going in and out of jails or institutions. And as social workers, we need to be able to be involved on a multi-systematic level, be able to help these different entities come up with ways to prevent certain aspects of these predispositions, I should say, or even helping to create these the best interventions that may meet this particular population's needs. So the nature of this problem is very serious, as our youth are our future, so what they do now sets them up for what they'll be able to do as adults. In this study, the research questions that the authors seek out are to figure out, one, among the delinquent females, what are the personal and family background variables which are useful in predicting female recidivism. So what does that mean? So that means what is going on, on a personal level within the homes, within the family dynamics that are affecting this population, and is there anything that we can identify as being a predicting factor? The second research question that we want to explore in this, that we will explore in this presentation, is to what extent can we predict membership in delinquent groups versus non-delinquent groups based on emotional behavior problems and early adverse family experiences. So what does that mean? That means, are there any factors that we can identify as far as emotional and problematic behavior? So like your mental health. Where does mental health play into this population? And how can mental health be an indicator of whether or not a female will become a delinquent or not? Start strong with the lasting energy of 100% whole grain Quaker oats. So looking at the hypothesis, unfortunately this study did not have a clearly specified hypothesis. So basically the authors never really clearly made a direct statement about any of the relationships between any of the variables they studied. However, they did note very specifically the research questions which we just reviewed.
Airborne's most powerful immune boost yet.
In the literature review section of the paper, the questions we were asked in the rubric to answer were the cited sources relevant to the study. And I believe in this article that the research, that the articles were relevant to the study. It also asked about were the references recent, within 10 years of publication, and I kind of can answer these two questions together. There were 30 articles, and all but 8 of them were within 10 years of publication of the study. But I believe that even the ones that were older were all relevant to the study, and this goes into answering The next another question in about the literature review, which is provide a short summary of themes of literature used by the authors to support the reason for examining the topic. And the reason I feel that the articles, even the older ones, are relevant to the study is because the theme of these articles were all why, what causes somebody to commit a crime more than once. The articles looked at things about how do we protect girls against delinquency, and what roles do adverse effects in early life play in juvenile delinquency. They looked at girls with mental health issues. They looked at child protective services, and they looked at psychiatric disorders in girls in the juvenile justice system. And just the topics all show a clear theme as to trying to find an answer on why girls become delinquent and what makes them commit crimes more than once. So I feel that they did a really good job on the articles that they reviewed. And the last question was, do the references represent a variety of discipline? And they also did a great job on that. There were articles written by people from the American Bar Association, from people in the field of social services. There were attorneys, sociologists, psychologists, psychiatrists, people from the Office of Juvenile Justice, members of the Department of Children and Health Services, and Administration for Children and Families. It just gave a really good, there were people from the Department of Education. So there just was a really good number of different disciplines, a big variety, but who all would have information relevant to this topic. The next section that I was asked to look at is the design and procedure questions. And the first question that we're asked to answer there was what type of quantitative study was used. The quantitative study used in this article was called a Cox regression study, which this test is also known as a proportional hazard regression test. And according to Barrett, Jew, Katanas, Zhang, I'm not sure I'm saying those names right, but this type of survival analysis typically examines how the risk of adverse outcomes over time changes in relation to possible covariant effects. So this test was used to examine the effects of race, family history of delinquency, income, event severity, and other issues, and how they, if that had an effect on these girls becoming delinquent, over time. And then, of course, the researchers used the chi-square test, and that test was used to determine data about behavior, mental health diagnoses, foster care placement, if a person received free lunches, and race. And this test is used to show the frequency of the variables in this group of delinquent girls and the non-delinquent group. And it answers whether, what happens. Is that due to strictly by chance, or is there something else that made it happen that frequently? The other question we were asked to answer for this section was, this a replication study or an original study? And this study is not a replication study. There have been studies done that were used to
Why don't you have your thing on when you walk,
answer
babe, if that helps?
some of the questions that were answered in this study, but there was no other, it didn't say that there was any other study that had all of the same things, and it just, so it was not a replication study. And then it asked was, why was the mythology useful for this scientific problem? And I believe that the mythology for this was very appropriate because the study used a large sample size. The data was collected from very credible sources, and the sample was representative of the population being studied. So, I just believe that they did a great job with the mythology in this study. The next section that I was asked to look at is the sample size. And the first question we were asked to answer there was what sampling method was used to obtain the sample. And what they did here was simply pulled records from the South Carolina Department of Juvenile Justice System, the Department of Social Services, Department of Mental Health, Department of Education, and they used these records to pull information that was pertinent to the study. The next question is, who were the participants? And the participants were, and this will also tell you, answer the question as to the number of people, how many participants were in the study. The participants were 34,614 female juveniles between the ages of 5 and 19 when they were first referred to and had gone through the South Carolina Department of Juvenile Justice. But there also part of the sample was 99,602 female girls who were born the same year, were of the same ethnicity and gender as the girls in the delinquent sample, and they came from records from the Department of Education and some of those other places that I named earlier. So that is where our sample, who our participants are, how many there were, and the next question is, what were the vulnerabilities of the population who participated in the study? And I feel that the people in this study who had any vulnerabilities were the juvenile offenders, because juvenile records are usually sealed, and if by somehow through this study the records, could have got out, or information could have somehow got out, letting people know that any of these girls were a juvenile offender, it could affect the jobs that they could get, perhaps the college that they could be admitted to, or even just how they were treated by other people. So I feel that that is where the vulnerability lies within this particular study.
The variables identified in the studies are listed as followed. The independent variables noted were gender and race, family delinquency, family income, drug use history, and first referral severity. So more specifically, that just means, on the first offense, what was the severity of the charge, whether or not it was a felony or not, or a misdemeanor. That's what it means as far as the referral severity. And for the dependent variables, we have the delinquent and non-delinquent. What I believe the tools of measurement were used for this study was the regression. And that's a statistical measure that attempts to determine the strength of the relationship between one dependent variable and a series of other changing variables, which are the independent variables. So trying to study the relationship, the strength of the relationship between these variables. So how strongly does race and gender and family delinquency and family income and drug use history and the severity of the first referral, how strongly does that affect whether or not one of the females would be considered a delinquent or non-delinquent? So looking at the data collection, so the data was collected from South Carolina's Department of Juvenile Justice Management Information System. And the information collected was taken from intake, and it was done by an officer. So the information was usually gathered or collected from the child's parent or guardian, and the information that was pulled for the study were the information regarding the child's gender, their ethnicity, their date of birth, the nature of their referral offense, the family income, the family history of delinquency, the child's substance abuse history, their educational history, and the family structure. So all of that information was taken from those intake assessments. Data analysis and finding. What were the major findings? So in the article, the study found that for the influences on recidivism, that the younger the offender at first offense, the higher the chance of another offense. Offenders with a drug history were twice as likely to have another offense than those without a history of drug use. Offenders who committed a less severe offense were more likely to commit another offense than those who committed a serious offense. Offenders with a family history of criminal background were more likely to offend more than once. In regards to the delinquents compared to the non-delinquents, there were more girls in the delinquent groups than the non-delinquent group who received free lunches, which was a sign of socioeconomic status. More females from the delinquent group had been in foster care through Child Protective Services, but the strongest predictor of delinquency were the girls with a DSM-5 diagnosis of aggression disorder. These girls were 11 times more likely to be delinquent than those without the diagnosis. How was this data analyzed? So a Cox regression analysis was used to determine the effects of the different variables mentioned on recidivism. A chi-square test was used to look at the frequency of demographic variables between the delinquents and non-delinquent groups to help determine what might cause delinquency. How was the data presented? The authors of the article used a number of tables to present a variety of different data. One table presented demographic characteristics of delinquent females, a second gave the results of the Cox regression analysis, and a third showed characteristics for delinquent and non-delinquent groups, and the fourth table showed coefficients for predictions of delinquency. So continuing with the data analysis and findings, the descriptive statistics presented was the measures associated with the chi-square test. The findings that were noted that supported the research questions were, for question number 1, the research question was, among the delinquent females, what are the personal and family background variables which are useful in predicting female recidivism? And in the findings, they found that the effect of family criminal history was significant, and that offenders with family criminal history background were at high risk for recidivism. Also, for research question number 2, the question was, to what extent can we predict membership in the delinquent group versus the non-delinquent control group on the basis of females' emotional/behavioral problems and early adverse family experiences? So what they found in the findings was the strongest predictor of delinquency was a mental health diagnosis related to a disorder of aggression. Female juveniles identified as aggressive were 11 times more likely to be delinquent than those without such a DSM-5 diagnosis. Conclusions and implications. So, there were 4 limitations identified specifically by the authors of the study. One being that the data was only collected from one state, which was South Carolina, and that really is a limitation, because how can that represent the national sample when all we have is the information from one state when other states have different factors and indicators and specifications that they look for, so that's kind of skewed. The second one is that the background information that was collected was only collected on the delinquent youth, not the non-delinquent youth. That information wasn't available because the information was collected based on the youth that had entered into the juvenile system, the juvenile justice system, I'm sorry. Then number 3, so the small number of samples that represented a race other than African American and Caucasian were not represented in the study. So the study is pretty much based off of 2 races, African American and Caucasian, which gives us no information about how, what indicators could be prevalent in the other races. The fourth one is that the study only used extreme indicators of family dysfunction in the study. So, extreme being the family criminal history. That's extreme. There were no minor family dysfunctions that were used as possible variables. So, what were the implications discussed? So, interventions that help adolescent girls learn how to manage their risk, so their trauma, so, any intervention that can help teach these youth to deal with the trauma that they may have experienced and, can help with preventing this recidivism. If there was an intervention in place to help these youth outside of just the juvenile justice system, then there may be a decrease in the delinquency rate. Also, the more mental health treatment is necessary within the female juvenile delinquent population because they have, remember, it was the highest, the mental health aspect was the highest indicator, as we read previously, that links these female juveniles to recidivism, continuing this process. So who will these results and conclusions affect? So the results and conclusions of this study affect the high-risk juvenile females, schools, communities, families, and correctional facilities. So that's why it's important to, like the recommendation of the study is, it's important to take a multi-systemic approach to help increase preventative measures and interventions to meet the needs of these female juvenile delinquents. So we know that they have a problem. We know that this is a problem, but we have to, as a system, as these different systems, we have to come together and, help address the female's needs for consistent nurturing relationship that provide healthy models of academic and social success, and then there may be a hope of preventing, this female delinquency issue.
And the last section that I was assigned to look at is the statistical test, which was, as I mentioned earlier, the chi-square test. And I'm asked to teach the class about the test, tell you when it's used, and then use a video to help describe that. So, a chi-square test is called a non-parametric test, and it is used when we cannot assume that the variance is normally distributed. So, if a person wants to know the frequency of something occurring, and did it happen by chance, or did it happen for another reason, we use the chi-square test. I have posted a link to a video below that will give you a much better explanation of what a chi-square test is, what it's used for, what the formula is, and how you perform it. So if you please click on the link, you'll be able to see that video. Thank you very much.
Hi, it's Mr. Anderson, and welcome to my podcast on the chi-squared test. Chi-squared test, if you look at the equation, lots of students get scared right away. It's really simple once you figure it out. So don't be scared away, but chi-squared test, especially in AP Biology, especially in science, is very important. And it's a way to compare, when you collect data, is the variation in your data just due to chance, or is it due to one of the variables that you're actually testing? And so the first thing you should figure out is what do all these variables mean? So the first one, this right here, stands for chi-squared. And so this was developed way in the early part of the 1900s by Carl Pearson, Pearson's chi-squared test. So what is this then? That is going to be a sum. So we're going to add up a number of values in a chi-squared test. What does the O stand for? Well, that's going to be the data that you actually collect. And so we call that observed data. And then the E values are going to be the expected values. And so if you're ever doing an experiment, you can actually figure out your expected values before you start. And then you just simply compare them to your observed values. Let me give you an example of that with these coins over here. Let's say I flip a coin 100 times, and I get 62 heads, and I get 38 tails. Well, is that due to just chance, or is there something wrong with the coin or the way that I'm flipping the coin? So the chi-squared test allows us to actually answer that. So what I'm thinking in my head is something called a null hypothesis. And so if we're flipping a coin 100 times, and I think I said 62 heads and 38 tails, well, that would be the observed value that we get in an experiment. But there'd also be expected values, because you know that it should be 50 heads and 50 tails. And so you use something called a null hypothesis in this case, where you're saying that there's no statistical significant difference between the observed values and the expected frequencies that we expect to get, and then what do we actually find. And so it's cool, chi-squared, because we can actually measure our data, or look at our data, and we can see is there a statistical difference between those two. The best way to get good at chi-squared is actually to do some problems. Before we get to that, there's two terms that I have to define. One is degrees of freedom, and then one is critical values. And so the whole point of a chi-squared test is either to accept or reject our null hypothesis. And so you have to either exceed or don't exceed your critical value. But first of all, we have to figure out where that number is in this big chart right here. First thing is something called degrees of freedom. So since we're comparing outcomes, you have to have at least two outcomes in your experiment. So in this case, if we have heads and tails, we have two outcomes that we could get. So we'll say that's 2. And then you simply subtract the number 1 from that to get the degrees of freedom. And so in this case, we have 2 outcomes minus 1, and so we would have 1 degree of freedom. Now you might think to yourself, why isn't there a 0 on this chart? Well, if you just have one outcome, you have nothing to compare it to. So that's an easy way to think about that. So we figured out that there is 1 degree of freedom in this case. Next thing you're looking at is for a critical value. And the critical value that we'll always use in this class is the 0.05 value. And so that's going to be this column right here. So the first thing you do is you find the 0.05 value, and you don't worry about all the other numbers. So that's 3.841 is something I just know because it means that I'm in the right chart, or I'm in the right column. A way that I explain this to kids is that you can think of that as being 95% sure that you're either accepting or rejecting your null hypothesis. And you can see that our critical values get higher over here. So you can think as we move this way, if we really want to be sure, we'd have to exceed a higher critical value. So what's our null hypothesis again? Null hypothesis, no statistical difference between observed and expected. And so we either accept or reject that value. So in this case, our critical value would be 3.841. And so when you calculate chi-squared, if you get a number that is higher than 3.841, then you reject that null hypothesis. And so there actually is something, aside from just chance, that is causing you to get more heads than tails. And if you don't exceed the critical value, then you accept that null hypothesis. And this is usually what ends up happening, unless you have a variable that's impacting your results. And so let's apply this in a couple of different cases. So this is my wife here. I asked her to flip a coin. And so I asked the statistics teacher, how much data do you have to get before you can actually apply the chi-squared test? And Mr. Hamburger said something magic about 30. And so I wanted to exceed that number in each of these experiments. And so this is my wife down here. This is her hand. And what she's going to do is she's going to, let me get a value you can see. She's going to flip 50 coins. You can see she's really fast. So she's flipping 50 coins, and then she's sorting them out. And so if we look at that, the first thing, even before you collect the data, is we could look at the expected values. And so we've got heads or tails. And so if you flip 50 coins, how many do we expect to come up as heads? The right answer would be 25. And how many would we expect to come up as tails? 25 as well. Now let's say your data's not as even as that. If you're looking at fruit flies, it might be 134 or 133. Well, let's say I flip 51 coins, for example, instead of 50. Then my expected values would be 25.5 and 25.5. So expected values, since they're just due to probability, don't have to be a whole number. If we look at our observed values, well, let's look down here. How many heads did we get? So this would be 25. So that would be 28 heads. And how many tails did we get? So that'd just be 22. Okay. So now we're going to apply chi-squared and come up with a critical value. And so what does that mean? Well, let me get this out of the way. So we're going to take our equation, which is O minus E squared over E. And we're going to do that for the heads column, and then we're going to do it for the tails column. So we've also got O minus E squared over E for the tails column. And so our observed value is going to be 28. So it's 28 minus 25, which is expected, squared over 25. Now this sum means that we're going to add these two values together. So I'm going to put a plus sign right here. Now we're going to do the tail side. So what's our observed is 22 minus 25 squared over 25. So you can do this in your head. 28 minus 25 is 3. Square that is 9 over 25 plus 22 minus 25 is negative 3 squared is 9 over 25. And so our answer is 18 over 25, which equals 0.72. Okay, so that's our chi-squared value for this data that we just collected. Now let's go over here to our critical values. Well, we said that we had 1 degree of freedom because there's 2 outcomes. 2 minus 1 is 1, so we're in this right here, in this row right here. And then here is our magical 0.05 column. And so our critical value is 3.841. And so if we get a number higher than that, we reject our null hypothesis. We didn't. So we got a value that is lower than that, 0.72. So that means that we have to accept our null hypothesis. That means that my wife did a great job. There's nothing wrong with the coins. We didn't. There's not way more heads than there should be, and so we have to accept the null hypothesis that there's no statistical difference between what we observe and what we expect to see. So now let's try a little more complex problem. Now we've got dice. So we've got 36 dice. So let me get this out here. So our expected values. Well, there are 6 things that you could get. So you could get a 1, a 2, a 3, 4, 5, and a 6. And so let's play this out. So expected values, since I have 36 dice here, we would expect to get 6 of each of those numbers coming up. So I'm just taking 36 total dice divided by 6, so I get 6. But let's see what we get for observed value. Oh, it looks like we're getting a lot of 6s. So if we look at the observed values, for 1 here we get 2 1s. If we look at the 2s, we get 4 of those. For the 3s, it looks like we get 1, 2, 3, 4, 5, 6, 7, 8 3s. For the 4s, we get 1, 2, 3, 4, 9. For the 5s, we just get 3. And then for the 6s, look at all the 6s. Now we have to figure out a chi-square value, so let's get this out of the way. And I'm going to stop talking and do the math and speed up the video a little bit. And so hopefully I don't screw up any of this.
Stop it!
Good.
is 58 over 6, which is 9.6. So that is our chi-squared value is 9.6 in this case, since we added all these up. So now we got to go over here to our chart. And so first of all, we have to figure out how many degrees of freedom do we have. Well, since there are 6 different outcomes, and we take 6 minus 1, so we've got 9. We're in this column of the 0.05 right here, so if I read across, our critical value is 11.07. And so if we look at that, did our value go higher than that? No, it's only 9.6. It's lower than that. So in this case, since it's 9.6, even though we had all of those 6s, we still need to accept our null hypothesis that there is no statistical significance between, or difference between what we observed and what we expected. So now let's leave you with this question. So in the animal behavior podcast, as I talk about that, we're looking at pill bugs and if they spend more time in the wet or if they spend more time in the dry. And so if you look at the values right here, this is recording how much time they spend in the wet and how much time they spend in the dry. So what I've done is we would expect, since there are 10 pill bugs, we'd have 5 on each side. But since it looks like they're spending more time on the wet, you can even see them in the video here, spending more time in the wet, I take the average of the wet and the average of the dry column. And that gives me my wet and dry. And so now I'm not going to show you how to do this one, but try to apply chi-squared to figure out if there's a statistical difference between the expected values, what we would expect, and what we observe. And you can put your answer down in the comments. So I hope that's helpful.
So when you want an immunity boost, take action with Airborne Dual Action. Airborne's most powerful immune boost yet.
So here is a web resource that I found that can help
Does your mouth often feel
further
dry?
explain the
A
video
dry mouth can be a
that
side
Sherry
effect of
had
many medications,
found
but it can
for you
also
guys to
indicate
help break
bad
down the
breath.
chi-square test.
That's why there's Biotin. Available as
And
normal
lastly,
rinse,
here's a list
toothpaste,
of our
spray, or
references.
gel.
Sherry and I would like
provides
to thank you for your
relief.
time and your
And it helps keep
patience
your mouth
with us
healthy, too.
as we
Remember,
discuss
while
this
your
issue.
medication is doing
We
its job,
hope that
a
maybe
dry
one
mouth
day
is
you
Biotin for
can
people who
make a
suffer from a
difference
dry
in
mouth.
the lives of these women if you happen to work in the field of social work and have a passion for our youth. Thank you for your time.